Okay, welcome to page 2. Starting off here. This time instead of giving a picture, we have to sketch our own picture. We have this triangle here. So this is a large angle, so I'm going to make a larger angled triangle. This is 127 degrees. And then we have, this is angle C. Then we have A and B. It doesn't matter how we label those, but we know that side B is 9 kilometers. So that right there is 9 kilometers. And we know that side C, so across from here, is 17 kilometers, which gives us a side-side angle triangle. So that means that we're going to use law of sines. So let's start with our completed ratio here. Sine, get right here in the middle of my workspace. Sine of 127 divided by 17. And then we are also given b, so I'm going to go sine b over, there's given lowercase b, over 9. So we're going to cross multiply 9 times sine 127 is going to be equal to 17 times sine b. I'm going to get the sine b by itself and just divide both sides by 17. Like that. We have to do inverse sine to get b by itself, so we will take the inverse sine of both sides, which will tell us that angle b is equal to inverse sine. We got, make a little fraction here, 9 sine 27 divided by 17. And I get 1327. Oh, sorry, this would be 127, not 27. 127. 127. So that gives me 25.0119. Make sure that is right. Yep. So that gives us angle B is equal to 25.01. But because we use inverse sine, or angle B is equal to, we need to do the second answer here. So 180 minus 25, 154. 99. But we already have an obtuse angle, so this is too big. It can't be that. That means that angle B must be 25.01 degrees. Now we're going to do the same thing over here. But this time, we don't have a completed ratio over here. So this needs to be sine of some angle divided by whatever our missing side is. So we need to find angle A first. So we need this guy right here. But we already have angle B and angle C, so we can just do 180 minus both of those, minus 127 minus 25.01. And that gives us angle A being 27.99. So we can plug that in here, 27.99 divided by lowercase a. Cross multiply again, and that will give us 17 sine 27.99 is equal to a times sine of 127. So if I divide both sides by sine of 127, I would get a by itself. All those fun ratios. And we type this in. 17 sine 27.99 divided by sine of 127. And that gives us 9.99. So A is equal to 9.99. 9.99 kilometers. And put degrees there. Okay, now we just need an area. I'm going to use two of the givens here, and then I will also use angle A. So my area will equal 1/2 9 17 sine of 9.99. So that should give us 0.5 times 9 times 17. That's a plus sign. 9 times 17 times sine of 9.99. Syntax error. Syntax error means I put a typo in here. Where was it? It's right there. Too many multiplications. 0.5 times, oh, I'm missing a times 9 times 17. 13.27. That is, what did I do wrong there? 9, 17, and lowercase a is 20. Oh, I'm bad. Not 9.99 degrees. This should be 27.99. That number did look way off. Try this again. 0.5 times 9 times 17 times sine of 27.99. There, 35.90. Hopefully that one is right. I'm pretty sure it is. That looks much more reasonable than the other number. Kilometers squared. Okay. Next up, we have another triangle that's given to us. We have angle A, so I'll start by drawing that. 72 degrees, so that's slightly less than 90, so we'll make a slightly less than 90-degree angle there. 72 degrees. And this is A, so we're going to call this one B and call this one C. And then it tells us that C is equal to 34 yards, and A is equal to, C is equal to 34 over here. And A, what is it? A is equal to 14. So I have another side-side angle. My completed ratio is sine of 72 divided by 14 is equal to sine C over 34. That looks weird. Like 72 is a pretty big angle. You can't have bigger angles than that. I mean, you can, but it'd be really tough. And this side is huge. So logically, this side should be across from 72. Let's see what happens. So let's cross multiply here. 34 times sine of, I guess I should write it down. 34 times sine 72 divided by 14 is equal to, oh, this should be blue, is equal to sine C. So we take inverse sine of both sides. Inverse sine. So we type in second inverse sine of 34 sine 72 divided by 14. Domain error, domain error. So, domain error means that either we typed in something wrong or it's not actually a triangle. And in this case, it is not a triangle. And that goes back to this being weird. 72 degrees, only 180 degrees are in a single triangle. So 72 degrees is fairly a good chunk of that. And this side right here is much, much bigger. Much, much bigger than this tiny side right here. So what it's saying is that there is no length for this side that could possibly work to make this one 34 and this one's such a small, small size. So really this triangle technically looks like you have a big long side over here. This is 72 degrees, so we can't change that angle. But this is only 14 yards, so there's no way that can reach all the way down. It just can't happen. Can't happen. So this triangle does not exist. Number six. To find a distance across a small lake, a surveyor has taken measurements shown. Find the distance across the lake. So we are looking for that distance right there, D. We measured 800 feet from this corner to our spot right here and 900 feet there. We're given side angle side. So we're going to use the law of cosines. So we get, and we're finding the side, finding a side. So we're going to use d squared is equal to 800 squared plus 900 squared minus 2 times 800 times 900 cosine of 70 degrees. Again, not a single variable on this side of the equation. That means we can just punch it into our calculator, and the calculator should make a smiley face. Squared plus 900 squared minus 2 times 800, 900 cosine 70. So we get that big number right there, but remember that number is squared, so we need to square root it. I guess I'll be a little thorough here and just jot that down. 95749.9936. And so now we want to take the square root of that big guy right there, and you get 978. So the distance across is 978.51. I think we're measuring feet. Done. Okay, a 113-foot tower is located on a hill and is inclined 34 degrees to the horizontal. A guy wire is to be attached to the top of the tower and to an anchor point at 98 feet up the hill from the base of the tower. and anchored. So find the length of the wire needed. So we're looking for this right here. We'll call it D because I don't like to use the letter L. Looks like a 1 and confuses me while I'm writing it. So we are given this angle right here, which is not part of our triangle. So that makes this a little bit confusing. This is probably the hardest question on here. You have to draw one extra line. And so what we're going to do is we're just going to move the ground up because we really don't care about this part right here. So we're going to draw a parallel line to the ground that intersects our triangle right here, just the point. It's hard to see that. Here, we'll do this. So we're going to draw right there. Now we have, so this currently looks something like this. That line, and we have that. We're going to have this right here, and this right here. And the extra line that we drew is going to be that guy right there. And this is 34 degrees. This right here is 113, and this right here is 98. So by just sort of moving this line up, this little extra chunk is just extra information. But we have two parallel lines with a transversal. So this right here is a corresponding angle with that. So that is also 34 degrees. And then we know that both of these added together have to be 90. So this right here inside the triangle is 54 degrees. So that gives us side angle side to find D. So with side angle side, we're going to use law of cosines. And so that gives us, we're finding a side, so it's going to be D squared is equal to 113 squared plus 98 squared minus 2 times 113 times 98 cosine of 56 degrees. I think I might say 56 degrees. And we punch that into our calculator. And if we want, we can go ahead and just square root both sides. And so we do second square root, type it all in at once. 113 squared plus 98 squared minus 2 times 113 and 98. 98 cosine 56. And we get 99.94. 99.94 feet. Ta-da! And that concludes page 2. See you guys for page 3.